Okay, we're going to do number 2 from the quiz right now. This is one where a toy gun is fired straight up into the air. Starts with a mass of 30 grams. You'll notice me pretty quickly convert that grams to kilograms. That's fairly standard behavior right there for most problems. Kinetic energy. The spring constant K is 140 newtons per meter. As a matter of fact, one of the reasons that kilogram has to be there is buried inside that newton, of course, is a kilogram meter over second squared. Displacement is 5 centimeters for the spring, or that's how much it is stretched from the top of the gun. Once again, go ahead and converting that to meters because, well, you can see that right there in the units that are already buried inside the problem. Now, one thing that you've noticed, most people did this problem pretty darn close, except one major issue, okay? And that's going to be resolved from drawing a decent picture in this particular case. Let's go ahead and set up the problem. Set mechanical energy initial equals mechanical energy final. We don't see very much friction in this problem, so we can pretty much stick by this guy right here. Now, as I do definitely going to be dealing with gravity and kinetic and elastic, I'm going to put all three of them on both sides. So I'm going to start with kinetic initial plus gravitational initial plus elastic initial is equal to kinetic final plus gravitational final plus kinetic final. Now, here's the major issue. For elastic energy, the zero has to be placed right here, okay? Why? Because that's the point of equilibrium. That's the end of the gun. That's when no more work is going to be done on that particular problem. You have to put the zero for elastic energy right there. So it won't have elastic energy when it's here or actually above. And it will definitely down here in the very beginning. So actually, let's just go ahead and use that real quick and knock that out. It's going to have elastic in the beginning. It's not going to have it at the top way up here. The issue is this. Okay, where do you place your zero energy for gravity? Because they don't necessarily have to go in the same spot. You could put them in the same spot. You could put 0 joules right here for gravitational energy next to the other 0 joules for elastic energy. Kind of confusing, I suppose. But note that they're in a different spot, because if you put your 0 for gravity there, then you definitely do have an initial gravitational energy, and it's negative. The way that you would address that is height initial would be -5 centimeters or -0.05 meters. Now, many people don't want to do that. So what they try to do is instead they move their 0 joules for gravity right there, which is completely fine. But you'll notice now your height final is not 0.3 meters. The problem specifically said, sorry, it's kind of hard to see that on the video, that it was shot 0.3 meters above the end of the gun, okay? Not from the very beginning, which of course means if I set my 0 for energy right there, then my height final is the 3 centimeters plus 30 centimeters up there, or 0.35 meters per height, and that's the major spot that people have. For the most part, the rest of this work is probably pretty accurate. They just had the wrong height in for the final. There shouldn't be any kinetic initial because it's not moving. There's no gravitational initial. If I put my 0 right here, it's all elastic. There will be kinetic final at the end because we are trying to find the speed right here at the end. Oops, question mark. Oops, I put kinetic final twice. My mistake. That should be elastic final. And actually, I think I canceled the wrong one. My apologies. So this elastic should have been what I canceled a minute ago when I said that was the case. My bad. Anyway, so let's go ahead and fill out these individual equations. This is 1/2 times k times delta x initial squared is equal to 1/2 mass velocity final squared plus mass times gravity times height final. And we're trying to find this guy right here. So let's start by subtracting that on the other side. 1/2 k delta x initial squared minus mass times gravity times height final is equal to 1/2 mass velocity final squared. Talking about canceling stuff. Could I cancel m? No, it's not in every term. It's in this one, it's in this one. It's not in this one. That being said, it can actually still simplify things. So let's divide that by mass to make that go away, and that would divide this term by mass. Same thing with the 1/2 actually. Can the 1/2 cancel? No, it's not in every single term, but multiplying by 2 would cancel here, and leave us with just a 2 right there. Actually makes things look a little bit cleaner. Square root both sides and plug in. So we should have, let's go to the other side here. K is 140 newtons per meter. delta x rather is 0.05 meters, because that's how far it's been stretched from equilibrium. Mass is 0.03 kilograms, kilograms here, minus 2 times gravity times height final is 0.35 meters. Square root that whole thing. If you've done it correctly, you should end up with about 2.2 meters per second. If you made the height mistake, you probably got 2.4 meters per second. That's number 2.